What's up, everybody? We are back again with another Redline Rebuild Explained. I'm Ben, the guy behind the camera for all this stuff.
And I'm Davin, in front of the camera, unfortunately.
At least from like here to here.
My body is in front of the camera.
Right.
Yes.
We try and keep your face out of it.
Yeah, that's always a good idea. But yeah, so Ben, this is our 389 rebuild, and it started slightly different than most of them.
It did. I mean, the first shot here is not a just engine covered in grime that we need to take apart. What do we have?
We have boxes of parts. A friend of mine asked me if I had any interest in a 389 Pontiac, and I said, sure, that sounds fantastic. I said, what kind of condition it is? He says, it's in boxes. I'm like, oh, okay. So I have a crate motor, basically.
It's a motor that's in a crate.
Right. By definition, he was correct. But ultimately, he had a Pontiac. He had collected some pieces of parts throughout the years. Got rid of that Pontiac automobile and had these left, and was one of those like, hey, I don't want to throw this away. It's a 60s motor, so on and so forth, which is pretty common relative to the hobby. Everyone has something that they've hung on to here or there. And so we had a lot of pieces. Some were for the Pontiac, some not. Some I still don't know what they're for. But this is us unloading the boxes.
This is a good shot of everything that we had. I mean, there were duplicates of things. Yep. There were, like you said, things that didn't belong to any sort of Pontiac anything. Right. So I guess, I mean, from this, we get everything out of the box. What was sort of the first step for you for the project? At this point
was an inventory of, okay, what we have, what can we even reuse? Obviously, the pistons, they were not worth trying to even bother reusing, and typically never are. Camshafts, the same thing. Unless you're in some kind of weird,
rods,
rare
though.
thing. Rods potentially could be reused. I mean, they need to check them for straightness and resize them. And then oil pans and some of that type of stuff we could reuse. And at the end of the day, they were rusted enough that it made sense just to buy new ones.
So here we have two different camshafts, plus a bunch of lifters on the on the right. All that stuff is
flat out paperweights.
Right. Turn it into a lamp or something.
Yeah.
Here's all of our pistons. Again, what you just said.
Which they were all the stock pistons.
So here's where things get exciting.
Yeah, so going into it, I knew the block had a hole in it. I'll say thankfully it was in a cylinder opposed to through the outside, because that's a whole different repair. So this is a fairly straightforward, put a sleeve in the block at this point. Since I have no history at all on the engine parts, so I really don't know what happened to it. Based on the fact that it's pushed, the piece there is pushed into the water jacket opposed to into the cylinder, tells me the block didn't freeze. It was some damage. The piston, came apart and the rod whacked it. I don't know that the rods I have are even the matching rods to that block.
Right, because you'd expect to see a mangled rod or something.
Yeah, exactly. So it was just...
Could have just been he just happened to get this...
got a deal on it.
Block.
Whatever it was.
Yeah. All right, so because we don't do the full teardown, obviously, it's already torn down for us.
Yeah.
The first place we end up is at good old Thurlby.
Yep. The first thing is decide if that block is usable. Obviously, it's already cleaned here. Went through that whole process, checked it for cracks, externally, internally.
So at this point, we're pretty sure that we can use it. So the next step is...
Yeah, so what you're seeing right here is, so Mike is concentrating on that bore that has the problem. And the idea is, as you cut this out, you want to see how far the cracks go. And if there's, if there isn't enough foundation there to hold the sleeve, then the whole block is just junk. It's time to start over. The cracks were contained well enough that we felt good about putting a sleeve in.
So meaning that it wasn't going into any other structural part of the block that if you were to put something in,
it didn't go across to the other cylinder
or go into one of the threads or another something where it's going to be spewing water into oil or vice versa, or pulling out studs or anything like that.
Correct. Yeah, so here it's all cleaned up to the point where it's ready for the sleeve, and he's just kind of checking that out from that standpoint.
Yeah, so he pulls it out. I mean, and again, checking it again. But this was I mean, you've probably had this done to blocks before. This was new to me and new to any of the videos that we've done. We haven't had to do this with anything yet, but I thought this part in particular, I was expecting him to get some sort of Loctite, some sort of glue, welded in, something.
Correct.
But there wasn't any of that.
No, and it's not a technically romantic function either. It's hammered in.
Yep.
Yeah, so one of the things that Mike likes to do is it's not cut all the way down, so there's actually left a little bit of a step at the very bottom.
So the new sleeve has something to stop against.
You're capturing it.
Okay.
So
it doesn't go through and hit the crank.
So typically you put 2 to 4 on a cast iron block. You usually put 2 to 4 thousandths of interference. So the hole is that much smaller than the sleeve.
Okay.
So you have a press fit in there. But of course, in the function of the engine running and cooling and that, you have expansion and contraction. So what you're doing, what he likes to do, or he found works really well, is so the sleeve doesn't move at all. He puts basically a stop at the bottom by just not going all the way down and leaving a little bit of an edge there.
And then the head's just holding it on the top.
And then the head sandwiches it in, exactly. But so when he's done in here, you'll see that it's raised up almost a 1/4 inch, which just puts it back in. So right here, he's in all the way. And like you said, there is no Loctite, there is no sealer from that function, because it's not going to, the press fit seals it all the way around if it's a good concentric hole. And you're going to have the seal that you're looking for, as far as oil and water and compression.
So back on to the machine, and at this point now,
Here he's going through now and boring the rest of the cylinders, because it's like, okay, that sleeve is, that hole is good, it's salvageable. Now we can bore everything and be done. Now here he's going to.
And you're doing that because you have to. You're doing that because you have to match. They all have to be the same.
Yeah, you want all the same piston size in there at the end of the day. And here he's just taking off the top edge of that, and he's going to rough cut it, so it's not, there's still just a hair. It's not dead perfect, because that's not what this process is for. This one is.
This process is for. So we've seen this a bunch. We've seen this in every video.
Correct.
But just give me the quick rundown of what this is doing.
So the rundown is it's running a cutter across the top of that deck and making it dead parallel and flat relative to the crank center line.
So we're starting here with the heads. And this is the sort of thing, this is stuff that we would normally do anyway, but was there any sort of more to think about since we didn't have a history with this? We didn't know.
Yeah.
We didn't know anything about where it came from. Is there anything we had to be? Was it just kind of a do everything?
Basically, at the end of the day, it was do everything. So we didn't have to. I mean, you go through and you check check items, but not knowing if these heads were overheated and warped and so on and so forth, and risking a guide or something being bad, we just put all new stuff after it. Knurled, where we could, we knurled guides opposed to replacing the guides. But but yeah, all the seats are replaced. I also like to do that on the exhaust side, just to have good, fresh, hardened seats. So
it's all apart.
It's all apart.
It's ready.
Now's the time to do it. But now you can run any fuel after it. It doesn't care. With the leaded versus unleaded fuel, yes, will it last forever with the softer exhaust seats relative to what this engine's going to see? 100%. Does it make sense to do that? No, it's just being cheap at that point. So here he's going through. You have a cutter. You're cutting in and cutting a new pocket, cutting the old seat out that was actually part of the casting, and now hammering in a new seat.
And that's what you're talking about with the leaded versus unleaded.
Yeah.
With these new seats now, you don't have to worry about it.
It's more right. It's more critical on the exhaust side than it is the intake side, but these heads needed both. They were pretty well used.
Now he's cutting these seats to fit the valves, and we had a couple questions on the YouTube video just about us not showing us lapping the valves, which you normally see the little wood dowel thing. They got
with a suction cup on it.
Yep.
Yeah, exactly. So traditionally speaking, seats were ground. They were not cut. So it had a stone that you went in there and spun, and you got your seat. And you put a 45-degree seat in, and then a 44.5 degrees on your valve, which was also ground. So you have a grinding stone has
a wear factor to it.
It has a wear factor to it. They're not as accurate as in this application, they're not as accurate as doing a cutter. So today's technology is to use a cutter. So now the cutter goes in, it's perfectly 45 degrees at the mating of the two components. So now you get a perfect seal. So it's 45 on both of them. And really what's found is when you go through and you lap it, no matter how much you clean it, you still have lapping compound in there.
Okay, so that ends up
basically diamond dust, and it adds wear to the seats themselves, whatever's left, and then also into your guides. So
it goes everywhere at that point.
Yeah. So if you don't need to lap them because the cutters are better, you don't bother at this point.
So same deal here with the decking. Now, if you did have a warped head, this rescues that, or to a certain extent?
Yes. If it has a warped head, it will, any imperfection and flatness, it'll take that out. Okay. And now there's certainly a point where you can only go so far.
Right.
Because you run into two things. A, the valves will be hanging past the surface of the head, which could cause an issue. And then the other is, as you lower the head down, it starts to change the angle of your intake manifold, which is just something maybe to be aware of, because as you lower the head down, the gap, if you will, the heads pull away from the intake. So now sealing that intake up could get tricky if you're not careful.
All your different angles change.
Yes.
Now, can you make up for some of that by the size gasket that you put in there?
Correct. There are ways around it.
Okay. So if you do need to, let's say, save something that was badly warped or damaged or something like that, you could by taking up that space a different
Correct.
way.
Yep.
And you'll see as we go through here, and as we've done with all of these, you're always measuring stuff. And you're always measuring it twice, 3 times, 4 times. You're measuring it at the beginning. You're measuring it while you're doing this stuff. You're measuring it after, and then you're measuring it immediately before you install it.
Yep. Yeah, because at the end of the day, the only measurement that counts is the last one.
Right.
But you got to do all your homework going to the last one.
Well, and even with all those, we've had moments where we go, wait a minute.
100%.
Which is why you do all those same things every single time, so you catch it before you put the whole thing together, and then blow something up.
And it won't rotate.
All right, so more machine shop stuff. We are at this point.
So here we're disassembling the rod and piston setup, obviously, and turning those pistons into ashtrays.
Pistons are junk, but the rods.
Rods, we're going to see if we can use them, and ultimately, yes, we were able to use the set of rods that we had.
So what Mike's doing here is he's just taking them apart.
Yeah, and then here he's facing them off. You're facing off the two mating surfaces, so they're nice and clean. Now, granted, on that surface, as you face that, you bring the cap and rod tighter together, so it might be the right size across the cap, but top to bottom won't be, because it's going to be shorter distance. So it's you're turning it into an oval.
All right. Okay, oval or
slightly.
Like football shaped, like a super fat football, because it kind of has the point of where the two things come together.
Exactly.
Which takes you to
the next operation here eventually.
He's pushing in new.
Pushing in new studs, or pushing in new rod bolts, which these rod bolts are Oh my, 52 years old now. So probably a good idea to put new ones in.
It's just one of those things where it's like it's worth that extra little
it's cheap
expense.
Insurance. Yeah, I mean it's cheap insurance. Sure, could the factory rods hold up to 200 horse still? Yep. In 2,500 RPM, most likely. But for $50 at this point, that's nothing.
And we'll talk more about it sort of toward the end of, we always get questions of how much would this cost, would this cost me to build, and we'll cover that, but part of, as we talk about all these things, as we eventually talk about all the other bits and pieces that we added to this build, it's important to think that like we're doing everything to the like
safe degree.
Right. The could you reuse this? Yes.
Right.
Should you? Probably not. If you needed to penny pinch, there are spots maybe where you could do it. But here we're like, we want to build this thing and we want it to be able to last. Yeah. And that's it.
And there'll be the argument of, well, if you're doing it that way, then why didn't you just buy brand new rods? Well, you're right. I mean, at the end of the day, what did we really save money-wise by reusing these rods, reconditioning? By the time you add all the machine shop efforts, you're right. We could have bought brand new rods.
For sure, but
for probably another $50.
Right. When you look at this build in particular, where we're coming from this bucket of parts, there was a certain aspect of it where we wanted to use as much as we could, because then at that point, then it's just we just bought all the parts and we slapped it together.
Yeah. At that point, you might as well buy a creep motor and be, I don't know, just kicking back.
So the whole mindset of us like, we're resurrecting this 66 Pontiac GTO motor is the like, we want to like have actual parts from a 64 Pontiac.
This is
or 66 Pontiac.
This is what car people do. We're old car people because we like the old stuff, and we are recycling it. We are keeping it active, not just simply buying brand new stuff.
We're so green with these.
We're more green than the greenies. Yes, exactly.
So Mike's got a torque wrench here, and so he's obviously put the new bolts in, but now he's torquing stuff down, and what's the point of doing that?
Yeah, so brand new bolts in it, torque everything down as it's going to be used. So I think it's 45 on the new bolts.
As it's going to be installed in the motor.
As it's going to be installed in the motor, because you want to pull everything to size. So in a relaxed state, it's one size. Torque down, it's another. Just like when we go and measure we put the bearing shells in, and we measure that size. The same principle.
We'll get to that.
So here he's going to torque everything down, and then go through and now he's going to resize them so they're correct. Take that football shape out. Because it's not a lot. You don't need a cutter. This is basically using it's a stone, a honing function.
So he hones it, and then there's a little
gauge up there his left that he's checking it with.
There he is, getting it, making sure it's to spec.
Yep.
And now this is something new for us.
This is the first time that I have ever watched a crankshaft being cut and then subsequently polished. So just when I said grinding stones aren't accurate, this is the way they are done. They are done with a grinding stone here.
A big grinding stone.
A very big grinding stone. And it's spaced and so on and so forth. Two separate styles of operation. This grinding stone would be capable of setting not only impressive surface finish, but also size in the millions.
Oh, really? I didn't realize that it was that accurate.
Oh, yes, yes. In fact, one of the things is to get you at perfect size, you run until spark out. So it basically stops sparking.
Okay.
Is a kind of a side note. I remember that from my engineering classes. Maybe some of the only things. Spark got me excited, I guess.
It was a cool process, and we actually took 2 cranks there because we had 2 cranks, and we figured, well, if we're going to go down there, we might as well just have them both done, and then we have an extra one sitting around for who knows another project, or somebody says, hey, you know what, I'm looking for a crank, and we're the best friend that says,
exactly right.
Hey, you know what?
I got one of those in the back.
But this was when we took this to Thurlby, and they don't do crank grinding there, but essentially Mark measured it and decided this isn't going to work.
Yep.
We can't.
And there was some wonkiness, if you remember, with this. Someone decided that I think it was one of the main bearings was a different size than all the rest.
Oh, that's right.
One rod was turned, and it was kind of like a head scratcher, because if you're going to go through the task of putting this on the lathe to turn it, you might as well turn them all.
Right.
Because once the setup is done, turning them all is nothing in time relative to the setup. So
yeah, one was 40, one was 30,
yeah, exactly.
one was
well, it was like a 10 and a 20 or somewhere in that range.
Yeah.
But
and so after that, we're like, okay, we need it ground. And then how do we figure out what it needs to be ground to and what other parts of the build that affects?
Right. So in this scenario, you are beholden to what's available, what bearing sizes are available.
Okay.
So, depending on the brand, there's different, in popularity, there's different clearances or sizes.
So, like, for instance,
so it'll
a
be,
Chevy small block, there's going to be way more options for bearings than there
but even
would
then,
for...
there's still not a ton. So you typically have like a 1 under. So basically, you polish a stock crank, but it's a thousandths undersize. So you get a thousandths oversized bearing. And now but then you typically have a 10, a 20, and a 30. And in this case, they also offered a 40.
Okay.
And then, of course, the other Chevys, they'll do that as well. But in the Pontiac, those were the ones that are available. There was some question whether the 40 was available or not. We confirmed that it was. So at the end of the day, you're trying to set clearances for oil. So you got to make sure you got bearings to work with that to get the clearance to where you want. So if you have, so in this process, again, this is capable to go to the millionths. So you can set your clearance exactly where you want it. So the best case scenario would be to take your bearings, say, no, all right, I'm going to cut this crank to 30 over. You take those bearings, put them in a block, measure everything, and then take that information to the crank grinder and say, okay, I want exactly 2.5 thousandths clearance.
Okay.
And he'll say, okay, cool, I know exactly what size I need to cut these to, and it will be dead on. Now, typical fashion is you send the crankshaft out, you get it cut 10 over, and then you go buy your bearings, and you're right there.
Yeah, close enough.
But if you're close enough, you're within a half a thou. So when you get into race type applications where things are really critical, that's where you would go and do it in that direction.
Okay. So that was pretty in depth, but we cut this to 40.
This crankshaft was 30. One was 30 and one was 40.
Okay.
I believe this one is the 30. So what is interesting though is it turns, the crankshaft turns, that stone does not rotate, it spins, but it does not move in and out. So when you have the crankshaft spinning, the mains are relative to the ends, right, centered, but the throws are not, or the rod bearing size.
It was one of the most visually disconcerting things that I've ever seen. Watching it spin in that, and I think I may have an iPhone video, maybe I'll put that in here, but you watch it go, and your brain can't,
it hurts.
You're used to watching a crankshaft spin on the mains.
Correct.
And once it rotates around one of the
rods,
all of a sudden your brain's like, no, wait,
can't work.
Does not compute.
Yes. and what allows that is this is a four-jaw chuck.
Not just close.
No.
Perfect.
Perfectly.
Perfect.
Yes.
The thing doesn't look like it's moving at all, and the whole.
So it flips from the Earth rotating about the sun to the sun rotating about the Earth.
Yeah.
So right here you can see that. So he is cutting a rod journal at that point, so you can see how far out that the throws are.
Yeah, it was cool. It was really cool.
And that's using a 4-jaw chuck instead of a kind of a 3-jaw chuck. Now this handheld, in this picture, that reminds me of like a handheld little chainsaw type of thing, but it has basically a piece of sandpaper on it. fine sandpaper, and that's just the polishing function. So you're not going to change the concentricity or roundness of that journal. It is what it is. It's rotating. That is that belt is spinning as well. So he's just going in and he's just putting the fine tune on it. I mean, if he changes it a millionth, I'd be surprised. It's just a micro polish.
Giving it the best possible surface because it's going to be spinning. Spinning a lot.
Yeah.
Cool.
Yeah.
Well, that was a lot. Hope you guys appreciate that. Sometimes we can go down rabbit holes, but it's cool stuff to learn.
And according to Doug at All Shaft, it takes a special person to run a grinder all day long. And after being there for most of the day, I 100% agree. It does take a special person because you are looking at very, very small numbers and ultra sensitive to size and that, and it's repetitive.
It's repetitive, but you can never not pay attention to the details. You can't shut your brain off.
Nope.
Fresh coat of paint, always.
Yep. Fresh coat of paint. Tape all the surfaces off that you don't want to scrape later, basically, what it amounts to. Obviously, you don't want to get paint inside the engine after you did all the cleaning process. I've always get this question. Why do you paint the motor first before it's all assembled? Because GM or Ford, they painted it all together. That's 100% correct. And they did that for a reason. I do it this way because if you ever walked into somebody's house where they taped off the trim and then painted, it never looks as good as the walls are painted and then the trim is painted and placed on. It's crisper, it looks better. Do I miss areas when I tape it off and I gotta go in and touch up where like the gasket, oh shoot, the gasket didn't go all the way out to the outside, it's halfway. Yes, 100%, always do. But at the end of the day, I think it looks better, I like it better. It's also less work because these parts are already clean. They're oil-free, they're ready to be painted. After a motor's assembled,
you got stuff
it's
everywhere.
oiled. You're oiled down. So just to avoid having to do things twice, this is the way I like to do it. Now, I don't have to tape off as much, obviously, once it's together, and that is why GM or the OEs typically painted them as one assembly.
Quantity versus quality sort of thing.
Yes.
All right. And we are in the shop. We're ready to put this thing together. We are in the new shop at this point, too. True. Now, this is something that, I mean, it goes by pretty quick in the video. Yes, it's obvious that you take all the tape off, but what are you doing here with the drill?
So here, you can do this at any point in the process. I'll say I like to do it before in theory, this should have been done before it was painted. But all I'm doing here is I'm chasing all the threaded holes for any kind of corrosion that from being, from the cleaning process to at this point, if it, got any rust in the holes. And of course you catch, just general garbage in them still. And
so you're smoothing things out for the assembly process.
Yeah,
making sure you don't put a bolt halfway in and then go, oh man, it doesn't go any farther.
It's broke off. Yeah, there's one at the bottom. And the other part of it is when we go through and assemble, we use torque wrenches. And we use torque wrenches for reasons of getting a consistent clamp load relative to whatever the specification is. So you're always looking for clamp load because torque is only equal to that clamp load when friction is a constant. So when they decided, hey, my clamp load needs to be X amount and it takes this amount of torque, they're also saying it has a constant mu of the surface, so you have the friction is a constant between the two. So point is, a rusted up thread and a smooth thread, you might torque it down to the same number, but your clamp load will not be the same.
Gotcha.
And that's also where it comes in when fastener manufacturers specify, this needs to be dry, or it needs to be oiled, or it needs my lubricant. That's why that stuff is there, is so you get the clamp load, ultimately even some bolt stretch, which helps that clamp load stay, or that part stay tightly together and not move relative to heat or changes in temperature.
Cool.
So long story, yes, going through and cleaning up all those. And then the fun part of putting in cam bearings. Of all the motors, we always have a little problem here or there with putting a cam bearing in. We remedied that with a brand new cam tool.
I think prior to this, though, we may have mangled one of these.
We might have. We might have.
It happens.
Yep.
And of course, you got to go in for both sides, so we...
Yeah, the engine stand limits you. You know, in theory, you could put them all on the table before you put it on the engine stand.
But sometimes you don't think that far enough in advance.
I don't think of that far forward.
It was probably me. I said, put it on the stand so I can get the shot.
It was all about the camera shot. And then your oil gallery plugs, freeze plugs. I like using the brass plugs. They look sexier than the steel ones. And brass has some advantage relative to sealing in general. And you can just see it in there. I use some high tack to seal around the freeze plugs.
Okay.
Just my process. And yes, the strength of a serpentine belt is impressive.
We have every video that we've done has commented on that. Actually, I think people really only commented, I think, about the Thurlby aspect of it, but we use it. Yeah. It works great.
Yeah. Yeah, one of these days I'm going to contact Gates and ask them what the strength of one is, just to have a number, because it's got to be way, way up there.
I know the company that I used to work for does all that stuff for all the climbing equipment, the pull strength thing.
Yeah, pull strength.
I can call them up and we could just
send them out one and have them
send them a couple belts and pull it and see.
I bet you it gets 8 miles long before it breaks.
Yeah, that, and I'll bet
because it's got nylon cords, so they're going to stretch as well.
Yeah.
So,
all right.
Anyhow, all right. So back to the assembly side. Cam bearings are in. They're in. So when you put cam bearings in, you have to place them relative to the saddles that they go into in the block, of course. And there's also a hole that you need to line up. Depending on the manufacturer, sometimes you line the hole in the bearing to the hole. Sometimes you clock it relative to a slot. There's all kinds of little caveats, company to company. All right, so cam bearings are lubed up. Here goes, in goes the camshaft. And this particular engine, it uses a camshaft retaining plate.
Okay.
That basically just holds it from walking out of the block.
All right. So you talked about this earlier in terms of, and this is similar to when Mike was torquing the rods down,
yes. Right? Yep. So here I put in every main cap with its respective bearing halves, and then you measure that size once it's fully clamped, because 40 foot-pounds of torque and 80 foot-pounds of torque will be about a thousandths difference in size. Because if I remember right, I did that at one point with, this is close enough, and then my oil clearance was too much, and then I'm like, maybe I should just torque it to spec and see, and it made a difference. It may or may not have been with this one.
But this is, again, just one of those checks. Yep. It's like, make sure that the bearings are correct. Make sure that the crank that we machined is correct. All right.
And now we put in the studs.
Now, are studs a factory or they would have been bolts?
No, for this particular engine, it would have been bolts from a factory installation. I like the studs whenever I can use them. I don't always use them, but
they look sexy.
When I do, they're impressive. And then assembly lube is what you see on every one of the journals. I over lube them because it doesn't matter. Having too much, too little could be a problem.
And that's all of the reason you're doing that is because none of that stuff turns and gets oil until you go to fire it up.
Till
if
you
it's
have
bone dry,
full pressure, right?
Then it's all sorts of bad things are going to happen.
And if you were going to fire this immediately, there's argument that you could run, just straight up engine oil on all the mains, because that's what it gets anyway. Mm-hmm. Yep, you're right. But for $6 roughly, that works every time, and you don't have to think about it.
And we have vacations, we have other projects, we have everything, and we don't know if we're going to assemble this part of it and then not come back to it for 3 weeks.
You don't know when you're going to fire it again. Yeah, exactly right.
Or in the case of the Hemi, you don't know that you're going to go and try and fire it and then find a whole bunch of water in the oil pan.
Maybe. Yeah, just exactly right. So we were talking about torque earlier and clamp load. So while we're putting these in here, these happen to be ARP studs, and they have their own thread lubricant for torquing things down. And they specify that the bottom of the, so the washer has to be lubed, the threads have to be lubed, and the face of the nut has to be lubed. And the idea is that it's a constant, it's a predictable torque that way.
You're not, the friction between the bolt and the washer, or the bolt and the caps doesn't restrict you getting an accurate torque reading and therefore the correct clamp.
Yes.
All right, and then time to have a little fun. Maybe I'll put the time-lapse, GoPro time-lapse in of me doing this shot.
Well, the hardest part about this shot is convincing the rods and the wrist pins and the pistons that they want to do this.
I bought them lunch.
Did you?
Yeah. I ate it all, but I bought them lunch.
So we have our brand new JE pistons, spiral locks, because we factory. So when Mike was pressing the wrist pins off the rods, I spec'd out on these what they call floating piston. So the rods, the wrist pin is floating. It has clearance relative to the big end of or the small end of the rod and the piston.
And therefore, you're using these.
Yeah, spiral locks which most people will curse, which I understand why.
Yeah, they can be a little pesky in the assembly process. So here you go. That was just a quick shot of you putting one in there.
Yeah.
Got a little teensy screwdriver.
And one of the reasons, now there are off-the-shelf pistons available for 389s, without a doubt. I want 9.5 to 1 compression so we can use pump gas and not have a lot of issues relative to spark knock and that. Factory-wise, these motors would have been closer to 10 to 1.
Oh, okay.
And with today's unleaded fuel and the ethanol and such, it would have spark knock issues. It would not like it.
Okay. Well, it's cool to think through all that stuff.
Yeah.
I mean, we were having a conversation earlier about just all the different things to engine building and what you're going to be using the engine for, from racing on a curvy track to racing in a straight line to wanting to race but also have it be a daily driver, to all the different things and all the things that you're adjusting.
Trying to balance.
Yeah, fuel efficiency to power to torque to everything. It's just, it's so cool, all the different spots where you can adjust things slightly to get what you want to get out of the engine. So here, you haven't put the rings on that piston there.
No.
So what are you checking here then?
So what I'm doing here is I'm degreeing in the camshaft. So the camshaft with that chain and the multiple positions on the gear on the crank side,
So how they
you
how
can
they
clock
line
them.
up.
Yep, you can clock them. So you can advance them, you can retard them. I wanted to put it in straight up, if you will, as the manufacturer spec'd out. There's always a little slight difference in where the keyway is in the crankshaft. You have a lot of tolerance stack up, a lot of parts that you're trying to deal with, and degreeing that in takes that out. It does not say that, it does not mean that if you have to advance it or retard it to make that number right, that does not mean that any of the parts were machined incorrectly. All that means is that variation, one was at one end, one was at the other, and this helps take that out. I don't need the rings in there because I just don't need the drag. Then all I need is the piston in there, really is just for top dead center, which is exactly what I'm doing there. So what you're doing is you're rotating the assembly, the piston up, and determining where top dead center is at, or where the top of that stroke is, and rotating the degree wheel to zero it. And now I'm using one of the lifters I'm going to use. Notice I'm using the outside of the lifter opposed to the center, and that's because I want a solid piece to extend.
Because it's a hydraulic lifter.
Yeah, it's a it's a hydraulic roller lifter. So nothing compresses except for in the hydraulic section, if you will, which is down in the inside. And all the hydraulic function is it takes up lash. Where in a solid lifter, you put lash in it or gap, so as the temperature changes, it doesn't go to solid, because that would be ugly.
Then
you potentially
everything would
leave a
lock
valve
up.
open is what happens. So here, just dial indicator, figuring out where it's at, and then adjusting things accordingly to get.
And then the thumbs up.
And then the thumbs up.
If you didn't catch that, it happens very quickly.
It does.
All right, so you have that done. So next step.
Next step is finish the assembly on the rods and pistons, putting the rings on. Put the oil, you know, your oil control ring, which is the corrugated looking section, and then there's an upper and lower relative to that, and then your secondary ring and your
All right, there's a good view
ring.
of it there.
Yeah.
All right, now this looks a similar clamp to what Mike had going on in the thing.
Yes.
What are you doing here?
So I'm doing exactly what Mike did, with exception of I'm putting the bearing in there now and measuring the bearing diameter, ID if you will, and comparing that to the crankshaft, OD, that tells me what my oil clearance is.
So again, another check to make sure that when we put it together, everything's going to still rotate.
Correct.
Have the correct
Which
clearances.
this is where we had 30 over bearings, but we were using the 40 over crank or something along that lines, which was why we measured it here. Because if we had just thrown it together, it would have clattered like the daylights and would not have been as, it would have been eventful when we started it up. We'll put it that way.
We got a little overzealous with the like, oh, we're going to save 2 cranks, and then confused ourselves by not realizing which one we were using. So it was a quick call to Thurlby, and we had another set of bearings.
The next day.
Yep. Yeah, that day ended early. We were like, all right, well, guess we're going home.
Yep.
They'll be here in the morning.
Yep, exactly. Exactly right. And you want to, you certainly, just like the lubing up the crankshaft or putting the assembly lube under, you don't want to put the pistons into a dry cylinder. So not only is the cylinder wiped down with just engine oil in this particular case, but then you also do the same thing with the rings. Piston skirts and the rings. This is the important part.
And your back and forth here is just inserting and then torquing the caps down on the rods.
And I saw we started with the ones, there's about 3 different ways to put pistons in a hole with the rings, because you have to compress the rings so they slip down in the hole. And so here we're using the OD clamp style and got frustrated with it. Some days it works, and I know it's all operator. Some days it works beautifully, and then
if it's all operator, then I'm surprised any of this works.
I hear you. So then our second choice was my old faithful adjustable sleeve.
And that worked like a champ.
Yeah.
So got one bank. Flip it around here, probably mostly because I said, I want the shot to be different, so do it this way.
That's right.
Yay. I love that this is open, because normally you wouldn't really get to see this aspect of it. I don't think we've done one yet where you have that open view of the camshaft.
No. Yeah, you get a good view of the camshaft without the lifters in the way. And
speaking of a good view, you get a good view of our fancy laser etched.
Yeah, look at that, huh?
Pistons.
Nice.
It's all in the details, man.
It is.
All right. Short block assembled.
Short block is assembled, yes. And in marches the valve train.
It's nice too that we can just sit back while it strips all its own tape off.
It's like having our own gremlins, that just work.
I want to say this shot. Mostly people just care about the engine stuff, but I'm just gonna toot my own horn here. I think that shot took me like 3 hours to do. You were off. You were doing something. No, not this day. There was.
Well, yeah, I'm obviously there now, but.
Well, yeah. No, but I think I did start out that day. You weren't there, and then I just had it ready to rock for when you rolled in.
Yep.
I'll notice here too. This is definitely during the summer because you're not the same pasty white that you are right now.
Exactly. That's correct.
Got a nice tan going.
Yeah. In fact, if I remember, it was fairly warm in the shop that day as well.
So walk me through what's going on here. You're pulling the valves and the springs off there, but you're not actually assembling anything right now.
Correct. So what I'm doing here is springs need to be, they have a, relative to the camshaft, you have a camshaft in there when you're talking about the full system. So you have your camshaft in, cam manufacturers will spec out a spring. So they want X, usually it's on seat pressure. So during installed height, meaning at rest, but installed, they want X amount of seat pressure. Well, springs are developed relative to seat pressure. So they'll tell you it is X amount of pounds at this height.
Oh, okay.
Okay, and there's, in fact, I took these springs, I had them over at Thoroughby's, and we checked them on a spring tester to make sure that spring load was really what it was supposed to be at that height.
Okay.
Now what I'm doing here is, okay, so now I know my springs are good, I know I get the right load, but now I got to make sure they're actually installed to the right height, otherwise that load won't be correct.
Okay. And that's factoring in the length of the valve, where the keepers sit on that, and everything.
And the pockets in the heads.
Okay.
And the where the valve is at, because that seat could be higher or lower down there. So again, you're back to a whole big stack up, and this is the last piece to say, you know, yes, my spring is where it needs to be height-wise.
And so if it's not what it needs to be, what do you do to adjust it?
So so let's say, for instance, that if the spring is not compressed enough, then you can put shims underneath the spring, between the head and the spring, and that brings it tighter. Now, if you need to, and you could also change the retainers and bring the retainer down lower.
Okay.
But typically, you will shim the springs one way or the other. If you get into the situation where you need more pocket, which actually we found out with these, you have to use a retainer that comes up higher to basically not compress the spring as much.
And when you say retainer, you mean the little clip? Or the...
On top of the springs right now is sitting, so...
Oh, okay, I got you.
So right here is the...
Yep.
That's the retainer. These are the keepers.
Keepers and retainers,
Yep.
okay. So many things, so many names.
So at some point you'll see...
So this little guy that you're using has measurement marks.
It's a micrometer.
Okay.
Yeah.
And hence all the numbers and everything.
Doodling. Yes. Not just doodling, I guess.
Keeping track of. Yeah. Okay, so you got everything set. You know what spacers you need.
Yeah, I'm happy with it.
And now it's assembly time.
Yeah, assembly time.
What are these little blue cap deals that you put on?
So, well, these are valve stem seals.
So just to keep oil from
going down the valve stem into the combustion chamber.
Oh yeah.
Or on the back side of the valve.
Get a little smoky.
Yeah, so typically most people are like, you don't have to have them on the exhaust. They're fairly correct. My thought is it doesn't cost me anything. So I put in the difference between the blue and the black ones that you can see there. The blue tends to be a little bit better seal. I put those on the intake, and I use the black on the exhaust side. Lots of times when a motor is burning oil or using oil, but you don't know where it's coming from, it's not leaking on the ground. Lots of times it is these intake seals, because that's the side that has suction, and it'll suck it right down the guide because there's nothing sealing the top of it.
Now
so a worn out guide or what have you will cause that. Okay.
And that's the sort of thing where if you determine that that's the problem, you can pull the heads when it's sitting in the car.
Yeah, you don't have to pull the whole engine out most of the time. You can pull just the heads off. Okay. And if one cylinder is sucking oil, do both of them. Never do one, because it makes no sense.
We've had that conversation here, and we always do.
It's a nice fresh start.
If you have it all apart, you might as well do everything, because pulling an engine out, just the pulling an engine out, let alone disassembling it to get to stuff, is obnoxious. You might as well do it right the first time. Spend the extra.
It'd be an extra hour by the time you pull the other head off.
Spend the extra time, spend the extra $100, spend the extra whatever, so you don't have to spend more money and more time later. Yeah. Now this is this factory? This is a part of your ARP?
Yep. So the studs are ARP. They're aftermarket studs, but factory would also use studs. But they referred to as a pedestal mount. So you just brought the rocker. They weren't adjustable. They brought the rocker to a specified height, and that was it. There was no real adjustment after that. I used these so I can adjust it. I take out with the fully adjustable rocker nuts and that, you can take out all that extra tolerance ring and stuff. But those are the factory guide plates that are on here.
Look at you showing off.
Magical.
using the force and rubbing it in by winking at us. More torquing.
Yep.
Always.
And these heads we went through and we cleaned up. You know, we did some mild porting.
That's right.
And it's mainly just cleaning up casting flaws and the natural edge that you get on the valve seat to the runner.
I'll drop a clip in of that.
Yeah.
Here for sure. That was one of the things where, I don't know, that the shot just didn't work out.
Yeah.
That we wanted it to be, and so it's just, we try to show everything, but you know, there are little things.
Sometimes things don't fit. Yeah.
And that was one of the things too. You spent what, 4 hours?
Man, about 4 to 6 hours on per head. Per cylinder.
I wasn't going to sit around and watch you do
No.
that. Heads are ready. Get the rest of the bits ready.
Yeah. Oh, I forgot we had I was thinking we left the sneak peek to the very end, but I forgot this intake was here at that point.
Oh, yeah.
So.
Well, it's kind of hinting at it. You don't see the
I didn't see the
full
carburetors,
setup,
but it's pretty obvious that
you know
it's
that there's 3 of them
Yeah.
going on there.
Lots of holes on the top.
And boom, into the timing cover. Which was, that was a part that we had, or that was a new one?
We did.
Okay.
Yep. We, may have been one of them that we salvaged the stud. We had to pull the stud out and a little video where we.
Oh, that's right. Yeah, there is a video
where
we use that. Forgot about that. Right on the drill press right there.
Yeah. Yeah. So we, so as a for instance here, so this is a little bit different than some of the motors. So this has a separate timing cover that's proud.
Okay.
A little more of the block than normal. And it also integrates the housing for the water pump.
Which we had to buy.
Nasty plates.
That was obnoxious.
Plates were painful.
Well, the thing is you had to get it to a point where it wouldn't rub on this.
Yep. And then we put an improved flow water pump on it. So those plates, I'll give you the stack up to give you the full water pump. Where if it's a completely external pump, you never see that, but it's in there.
It's a good looking water pump.
It is.
It's funny, something like that, you're never going to see it.
No.
And yet it still looks that cool.
But it's also, it's anodized for corrosion.
Okay.
I mean, there's reasons behind, because it's aluminum, aluminum vein, I guess.
You have an acidic.
Yeah. So you want to have some sort of protection on there.
Time for the heads.
Yes.
Now we basically, because of the way that this was and we didn't know what was what and everything, you essentially ordered a bolt kit for everything on this.
Yeah, because we had such a mismatch of pieces and parts, remember, in that box. Mm-hmm. It was hard telling what we had, so we just bought an engine assembly bolt kit.
Yep.
Now, what we're doing here, if you back up just a little bit, you notice that I put rocker arms on.
Oh yeah,
but not all the bolts are in.
Yep.
Right.
You actually, when we were reviewing this video, somebody was like, "It looks like he starts to do it, and then he pulls them off." Is our continuity off here? And I said, "No, actually, that's part of the of the process."
Basically, what so just like we did the checking the timing or degreeing in the camshaft, you also want to verify your clearances from your valves coming to their max travel. Don't crash into the piston, and there's appropriate space there. So that's that pre-assembly function. Again, all the bolts get some lube on them so they torque down appropriately, and there's a torque sequence, and the reason is so it pulls it in. Typically, torque sequences are from the center out, and
this is a good illustration of it. Actually, the top down. You go ready here, boom, 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 boom.
Yep.
Kind of a spiral.
Yep. And for whatever reason, it's either counterclockwise or clockwise. This one happens to be counterclockwise. But that's exactly it. So you just spiral out to the outsides, and it pulls everything down evenly that way.
And not only that, but the torque sequence, in that you can see that you do it multiple times. You're not torquing it the first one all the way and the second one all the way. You're doing it a little bit at a time.
Yeah. Yeah, so if it was, I don't remember the exact torque on that, but if it was 85 foot-pounds, you'll do 3 steps to get to 85. So you might do 25, 50, and 85 or some breakdown of that.
Now, one of these days where I didn't have you around, so I just had to ask the parts to...
I'm pretty sure I was here for this.
No, it's nice. I just get to stand behind the camera, hit the button once every 10 seconds or so, and
So again, back to the assembly lube. Everything's lubed up nice and well. Now, something that's different about these roller, I think this is the first roller motor we've done. Most of the time, these lifters are individuals, and they do not have this crossbar. So
yeah,
these are.
That do?
So what with a roller lifter? Remember, you have. I probably can't see it in any of the pictures, but you have a roller on the end of that lifter, and it has to. It's a cylinder, so it has to be lined up with the camshaft. It wouldn't work at all going the other direction. So the tie bar is what keeps the lifter from spinning. So in normal fashion, a flat tappet will rotate where these don't. They stay in. They just purely go up and down, and that tie bar keeps them from twisting.
Cool.
And the reason for roller camshafts is you can get a more aggressive cam profile, and of course less friction with a bearing. And then likewise with our Howard's rocker arms, they're full. They have a roller fulcrum.
Yeah, you can say. I think you get a better
full
view
roller
from
rockers.
here.
Yeah. In goes all the push rods.
Yeah, so there you can see you get a better view.
And
of
those trend push rods are nice.
Yeah.
To say.
Get a better view here of the rockers.
Yeah. And now these nuts, so these are your rocker nuts, if you will, and they have they're actually call it double threaded. So you have the big hex, which gives you your adjustment function, so that brings it up and down, and then the center cap screw is a lock function.
Okay.
It locks, it drives to the top of the stud in the head, and that locks that from loosening up or rotating. So instead, like factory would use a pinch nut.
Oh yeah, you can kind of see them start disappearing down in as you have.
Yeah, as you adjust it.
What are you setting here? So you're obviously going through and you're rotating the crank because you can see all the lifters moving.
So here I'm adjusting lash. So now this is a 0 lash because it's hydraulic, but you actually rotate it. So you bring it to 0 lash, and then because it's hydraulic, you give it, depending on cam manufacturer and lifters, a quarter to a half a turn, which but basically preloads that lifter by, it's like 20 to 40 thousandths roughly, depending on thread pitch. So that brings you in there, that takes up that slop, and they don't clatter. Okay. And you're getting the maximum lift at that point. But you have to go through and you have to be at the bottom. So you got to make sure that your lifter is at the base circle of the camshaft. So the big end of the egg, if you will. Okay. And that's why you have to rotate it, obviously, because they're all moving around. And then this is a stock crank scraper or windage tray, depending on who you talk to. And the idea,
so that was in our bin of parts.
That was in our bin of parts. Yep. So that was so as that bolts down to the main caps, the idea is you pull oil that is slinging about the counterweights on the crankshaft. It gets it off of there, reduces drag. Okay. And so of course, it gets it into the pan. It cools off quicker. You know, there's a couple different benefits. Yeah. Of course, a brand new oil pump. It's silly to reuse an oil pump.
And a brand new oil pan because we didn't have one.
Well, we had one, but it had a lot of crust to it. It was pretty holy.
So well, you can see your little wrench that you had to use. It was at an awkward angle in there to get those things. Yeah. And even getting them torqued was kind of awkward. And
that was a one-piece seal opposed to a rubber seal opposed to a
Oh yeah, I can drop that clip in as well. I didn't have it in here, but I remember seeing it in the edit. I can drop that clip in there of watching the gasket come in and sit around the pan.
So pan's on now. I'm putting, that is the oil filter adapter. So some blocks, like on a Ford block, actually the oil filter attaches directly to the block. Okay. This has an adapter to bring it 90 degrees.
But that's stock?
That is stock, yes. And there's 2 options depending on what kind of exhaust you have on it. These are ram air exhaust, factory exhaust. And
but what?
They're remanufactured. Okay. Yep, remanufactured originals style.
It's what would be on there, but they're brand new.
Correct.
And those.
And that's improved flow.
Did they come that way? Are they painting it, or are they?
So they come raw cast iron.
Okay.
And I have some high temp paint that I use that actually goes on gold, and then you bake it to like 550, 600 degrees, which I cannot do in my home oven. Mm-hmm. So I take them to a shop here in town that does some powder coating, and they'll bake it, and it turns that gray color, and it does not flake off.
Nice.
Like most of the spray paints. Here you have the fuel pump going in, and then I rotate the crankshaft a little bit so I can get, that's on a cam lobe as well. So rotate the crankshaft just so I'm not fighting it to put it in.
Because there's a spring in there.
Yeah, because, well, you got your arm that has a spring on it. Yeah. And then the balancer.
Which balancer and pulleys all were stuff that we had?
Yeah, yes. So this was, I thought was a little interesting with the Pontiac. So they do things a little different than I'm used to, at least. So on this one, you have a, as you back out here. So initially, stop, back up, right there. So here you have a hub, call it a hub adapter. Mm-hmm. So you have a crank hub that goes on and gets torqued down. Then you have the pulley, then the balancer ring. Now, typically speaking...
Oh, I see. Okay.
Right,
yep,
typically speaking, that balancer ring, the bigger, heavier section, would just be part of the crank pulley. Okay. But what this actually allows you to do is the pulleys can be tighter to the engine, so it helps free up some packaging space.
I gotcha.
And it does the same thing. It doesn't care where it's at as long as it's balanced. And these are all internally balanced. Right, now we're pouring in our Pennzoil. Use 20W50. It might be a little heavy for that, but it'll be fine. 2550.
And there were a few questions of folks asking why we weren't using a break-in oil, and that is because...
It's a roller cam. So the beauty, not only do you get ridiculous, you have better performance from a roller cam. Mm-hmm. You also don't have to go through that white-knuckled 2,500 RPM, 20-minute break-in period, and hope you did everything
Please
right.
Don't explode.
Yes.
Please don't explode.
Yes.
Please don't explode.
So yeah, with a roller cam, because you're not trying to break in metal surfaces sliding against each other, they're rolling, and you don't have that mating wear function.
Yeah. And then this process included, this time lapse included a very long pause while we waited for oil to come out of these.
Yes. Yep.
These little spots. I don't. Oh yeah, there you go. You finally see
just
the oil
start to
come
see them.
out.
Yeah. So what I'm doing here is I'm using a drill motor to spin the oil pump, and you're priming the whole system. So yes, we have assembly lube on everything, but you still run it up, still prime everything. You want to bring. I mean, look how long it took for the oil to come up the push rods and get into all the nooks and crannies. So.
Yeah, it would have been running for a minute or two.
Oh, at least. Yeah, with no oil to the rocker arms and cooling the springs. That's the other function of the oil at the top side. So it's best to do this, and then we finished by throwing the brass plugs. This is a valley pan here. So this doesn't, the intake manifold on some engines seals the valley where the lifters are at and mates to your heads. On this one, similar to like the Hemi, it has a valley pan that's separate, and then the intake manifold.
Now you can see here you install this gasket, but then you block off one of the ports. What are you doing that for? Yeah,
so factory heads always have a exhaust crossover, so it takes exhaust gas to the center of the motor, which accelerates the heating function of the engine. So it basically is heating the carburetor up, the center carburetor in this case, so it comes up to a better idle quicker.
Okay. And so why are you blocking it off?
And it's the choke pull off and that. I blocked it off because I didn't want the heat into the intake manifold, because when it's 200, when the engine comes up the temperature, you're still heating that intake manifold even more. And of course, you put as fuel gets hotter, you put less into the cylinders, and power starts to go down. Okay. So a typical thing is to block that off completely.
And that's just a performance thing. It might firing it up to begin with, it's not going to warm up as quickly. Right. But once it's
And where the only place you're going to see a negative side of blocking that off is starting it on a cold day, like 20 degrees or lower, 0, which will not happen.
Generally nowadays, you're not firing up your GTO to go drive
Typically
when it's
not.
20 degrees outside.
That's correct. Yep. Yep.
All right, getting everything torqued down once
Yep.
more.
And now we're.
Those are nice bolts you got there. Stainless.
Yep.
There they are.
And there they come.
What kind of carburetors are these?
So these are Rochester 2-barrel carburetors. Obviously 3 of them. We bought this as an assembly at the Hershey swap meet.
Oh, nice.
So kind of a cool tie too, because swap meets are a great place to find parts. The carburetors were all refurbished, ready to roll, and
had all the fuel line and everything, or did you have to?
Yeah, had all the fuel line, had everything for it. So completely disassembled it so we could paint the intake manifold to match the block and such.
And
that is the right color for 66.
Not cheap.
No, not cheap, but well worth it.
Well worth it.
Because there's nothing that looks cooler. I mean, face it, nothing looks cooler than that Tri-Power there. Now, every one of these, well, the outside carburetors are different than the center one, so that makes things difficult to find, and that is also part of the expense of it.
Mm-hmm. And when maybe this is a good time to talk about it. When we talk about the overall expense of putting this all together, we've talked a lot about the extra little details we do, hey, we're here, we might as well do it right. But we talk about this Tri-Power setup being a hefty chunk of the overall cost of doing this.
Yeah.
So let's, at this point, we're
done.
We're done. The main stuff. We got to run wires and all that stuff, but we'll get to that. Yay! Fresh rebuilt engine.
It's gorgeous.
If viewers sitting here with similar, whether it's boxes of parts or something sitting in the corner and they want to rebuild their 66 or 65 or 64 Pontiac, like what are they looking at in terms of
cost?
Yeah.
So what we have on our build, we figured out we got about $6,500 into it, and that includes obviously none of our labor.
Thanks for saying hour. I appreciate it.
Yeah. Well,
I hold some stuff sometimes.
Yeah. You did move those parts around a couple times. But no, so we have but that does include the machining cost, and we're not trying to shade anything relative to freebies and the machining into things. It is what it is. But so that price will change based on the condition of your parts in general. That's obvious.
We had to sleeve a cylinder, which
we had to sleeve a cylinder, which is typically over and above. It's purely salvaging a block that's a 66 GTO block. That's why we did that. The exhaust manifolds, you could use stock ones. You could buy headers cheaper than I paid for these, but it's what what you're after at that point. And you certainly could do a swap meet find here for $20-$30 opposed to, I think these were almost $3.
Yeah, there were a few things that we bought brand new just because that if we had the time or whatever and we really wanted to, we could have gotten an oil pan at a swap meet. We could have gotten a lot of different stuff. Right. And we could have gotten the Tri-Power not completely done and ready for us.
Well, we could have got that, exactly, or we had to go through and refurbish it, or we could have just flat out put the cheapest way would have been just finding any old stock 4-barrel intake manifold and putting a 4-barrel carburetor on. That is typically the cheapest route.
But that's not fun.
But that's not near as fun. Other things that we got into it from you wouldn't have to do, the roller cam and the lifters are about 60% more price-wise than just a standard hydraulic camshaft and rollers. And then, you could get away with your, stamped rocker arms. You don't need to have the full rollers, but the whole package makes sense at that point. Now you could go to the flip side of that, and you could buy aftermarket, heads. You could go aluminum. Which you could get into. Well, the sky's the limit, quite honestly, when you start going into that range. And a lot of power is made right here. Heads airflow makes all the difference in the world. Yep. We didn't get extravagant on rods. We have forged pistons, and they're custom because we wanted that compression ratio. You could have went to a different compression ratio, lower most likely.
So it's
anemic
it's
at
all
that point.
dependent on what you want to use it for, what
Yeah.
you're after. But would you call this, aside from going like super high performance or race or whatever, if you're just looking for like this is going in back in a car, it's going to be my daily driver, we're on the high end of that.
I would say so.
Of that sort of build type, and plus we didn't start with much.
Yeah, we didn't start. Yeah, I mean,
most people are going to come with at least a complete engine into this process.
Yeah, I mean, at the end of the day, we had pieces. So we had a block, we had a crank, we had rods, and we had heads. That's what and some pulleys. So we had that piece of things. Now, at the end of the day, you can you freshen up? If you had one of these that's running and you need to just do a quick freshen up, you could do it for probably $1,200. Meaning you bought rings and new gaskets and you ran a hone through the cylinders. But that's assuming you have something that runs fairly decent and you're just trying to get a little out of it.
Not essentially garbage picking and trying to make something out of it.
Right, which is more fun.
It is, and there's a certain satisfaction at the end of this where we're like, not to like, hey, you're a hero, Davin.
No.
That's kind of, that's part of what Hagerty's all about, is the idea of like saving driving and like we're into cars. You guys are into cars.
Yeah.
Like,
and what's more fun than making something out of nothing?
Oh man, that's awesome.
At the end of the day.
Yeah.
And then you get into the final piece here we have is it's got a fire. So it's got to have some ignition piece to it.
We get yelled at from people if we don't fire these things up.
Yeah, that's what I hear. Otherwise, they're just static museum displays.
And I agree. You want to hear this thing. I want to hear this thing roar.
Here we could have went with stock distributor, all those types of things. The MSD distributor is nice because everything is contained under the cap. It's an HEI style, meaning it's not points. It's electronic ignition.
It's cool. You wouldn't. I mean, it looks like it belongs there. Like
it does.
Like it would have been there in the
Absolutely,
60s.
Yeah.
Anything special about the plugs or the plug wires or anything like that?
No, just a I'll call it now standard 8mm plug wire and just a fuzz better plug as far as that goes, but nothing.
So there wasn't, in terms of the cam that we put in there and anything, there wasn't anything special that we had to do from an ignition standpoint?
No. And this is just putting some extension tubes on the exhaust.
There were some questions on the exhaust. You want to just fill us in on?
So on this note, on the exhaust, that long piece of pipe are the stock available head pipes for a GTO.
Okay.
So that made it nice. I didn't have to go to the muffler shop and have anything custom bent. So they're nice mandrel bends, nice and smooth, bolted up perfectly. Yeah, that's exactly. And happen to be stainless. And then the mufflers are Flowmaster 44s. They have personally a nice mellow sound to them.
All right,
And
fuel her up.
In goes some 93. Boom. Again, we're on our easy run test stand. It is very versatile. We've had, 3-4 different motors on this now?
Yeah.
With very minor, really all you're doing is changing is how it mounts to the block.
Yeah, it's all very modular. You haven't had to do any real custom anything, which has been great. All right.
And don't start your engine with your timing light stuffed in the hole. And those are factory holes, by the way, into that. They weren't drilled in there separately into that bell housing. That was to keep the converters cool.
All right, here we go.
That is the first attempt.
Yes.
Hence the fire.
Here, hold on. While we talk about it, I'm going to keep it on maybe this frame or one of these two.
Right there, it looks like it's coming out of my ear.
But this is no, there's no trickery here. This is as is. This was the first shot. This was That was literally the first time you turned the key to fire this thing up.
Exactly right. And at the end of the day, what it amounted to, there's extra fuel in it. It hit a little bit of a hiccup. Timing was only off by like 4 to 5 degrees. Okay. It was not like 180 off like normal or whatever. So it had to be dead on to be where it wouldn't do that. But hey, it made for great.
It made for awesome video. I mean that was the icing on the cake for this thing. I mean, me as the video guy, I saw that happen and I'm just like, yes. Yeah. Not only did it happen, but I got it on video and the shot was good. And your facial expression was priceless.
I was shocked. And let's keep in mind, some people tend to think that I'm not in my hazmat suit here, so this is a problem. I'm also not standing over the top of the carburetors because I know it will do that or can possibly happen.
Yeah, it's a possibility.
So I am not, leaning over.
I love that you were because of the, let's call it maybe, general issues that we've had, getting stuff to fire up the first time with all the builds that we've had. The funny thing is you get the eye thing there, and then you're looking, that you do the reaction before it backfires.
That's correct.
Or not backfires.
Because my reaction is, yes, this is running, hot damn.
You're giving me the I'm hot stuff.
I did it.
and then right in your belly. There's the reaction to that face there. That's a good one. That's a good freeze frame there. So yeah, it was little adjustment.
Little adjustment. Yep.
Yeah, there have been times where a week later we still don't quite have it running right, and this one, finally it fired and just behaved, and it sounded good.
Mm-hmm. Yep, set the timing, and that light is wonderful. I love that timing light.
Now, based on everything, all the different specs of cam and pistons and all the stuff that you did, what will this cruise at? What's its sort of red line? And then we'll get into some numbers here.
Right on. Stock wise, this motor would have been right around 360, 370 horse with a 389, which is awesome. What I'm looking at to be is a little closer to 400. So anytime I can get 1 horse per cube, it makes a very nice street engine. Now, I'm not going to be setting the world on fire drag racing by any means, but it's going to be fun. It'd be smiles per hour, smiles per mile. How's that sound? So in keeping that theme though too, as far as needing to be a streetable motor, it's fairly mild on it's a dual pattern camshaft, meaning the exhaust and the intake aren't exactly the same.
Okay.
So, lift is a 520, 525. So 520 intake, 525 on the exhaust. And then the duration has got a little bit of a split to it as well. And that gets into the overlap and a whole lot of weird theories of stuff and how it breathes. At the end of the day, low duration gives you torque, is more streetable. When you start to get in the much higher lift and a lot of duration, you get a lot of RPM out of them, but they're dogs on the street, and that's where somebody says, I overcammed my engine. Well, you did, because it can't move until it's 90 miles an hour, and it's like, holy smokes, hang on to your hat. But the idea is to keep it down at the bottom end.
Yep.
And then also this particular camshaft is what they call a 4/7 swap. So the 4/7 swap is, instead of the normal firing order, you actually swap the firing order, so 4 fires different. They swap when 4 and 7 swap, or fire. And what they found out is that by doing that, the engine tends to run a little smoother and actually makes more power. You get some exhaust scavenging that's a little bit better, and it flows more air through the engine by doing that.
There have been questions, what horsepower does it make? Or, you need to put it on a dyno, and we're going to try.
Yes.
We know a guy that has an engine dyno. We took the 289 down there
Yes. So we'll put the 389 on the engine dyno, and we'll see where it's at. Because obviously, free revving is different than under a load.
Yep.
You know, just like, I don't know, anything sitting still, you know, in the car versus getting after it is a different thing. So there'll be some tuning function, I'm sure, at that point. But at the same token, yeah, let's put this on a dyno and see where we're at. Because a little bit of porting work goes a ways. You know, there's a few little things to make things cleaner and better, and it should run and make a little more power than stock. I guarantee you, well, if it's 600 horse, you owe me lunch.
But there's no way, right?
It's not going to be.
So that's pretty much it. I think we've covered pretty much everything
all the questions, yeah.
that came up.
And that's my serious, I'm concentrating look.
How about that? Nice.
All right, sweet. Thank you, Ben.
Congratulations on another well done build.
And the video was very nicely done.
Thank you.
I have to say, the editing is phenomenal.
It was it was fun with all the stop motion stuff, and I don't know, it's just fun putting these together.
It is. I agree.
You enjoy your job, I enjoy my job. It all comes together with something that we're pretty proud of. So
yes, for sure.
Thanks for watching, guys. If you made it this long, hope you learned something. Subscribe, like, comment, all that fun stuff. Exactly. And we'll be back in another couple months with another Redline Rebuild. In the meantime, check out Barn Find Hunter, check out DIYs, check out YI Drives. We got lots of cool stuff. Check it out.
See ya.
See ya.